How do SCADA system alarms function? Imagine a busy control room where operators are constantly watching screens and listening for alerts. That's how supervisory control and data acquisition systems keep everything running smoothly. These systems are the backbone of many electrical and industrial setups. They work by keeping an on real-time data from equipment like transformers, turbines, or robotic arms. When something unusual happens, alarms are triggered to warn the operators immediately. SCADA systems gather data from field devices called remote terminal units and programmable logic controllers. These devices are like the system's sensors, monitoring voltage, current, temperature, and pressure. They send this information to the central SCADA computer. The software then compares the incoming data to preset limits. If a value exceeds or drops below these limits, an alarm is generated. For example, if a transformer's temperature gets too high, the system will sound an alarm. Alarms are not all the same. They are prioritized based on how serious the issue is. Critical alarms might be red and flashing, while less urgent ones could be yellow or steady. The system displays these alarms visually on screens and also plays sounds to catch attention. Operators can acknowledge alarms, add notes, or even send commands to fix issues remotely through the interface. Managing alarms is an important part of SCADA. The system groups alarms by type and severity to prevent overload. It can filter out false alarms or repeated alerts that aren't urgent. Advanced SCADA systems also diagnose alarms to identify false triggers or alarm floods, which happen when many alarms go off at once. This helps engineers fine-tune the system for better reliability. In electrical engineering, alarms help prevent damage by catching faults early. They alert operators to problems like equipment failure, overloads, or abnormal conditions. This early warning allows quick action, reducing downtime and avoiding costly repairs. When integrated with automation, SCADA can even trigger protective actions automatically. For example, it might open a breaker or shut down a machine if a critical alarm occurs. In real-world applications, alarms are everywhere. In power plants, alarms might signal turbine speed issues or generator overheating. In industrial factories, they could warn of pressure leaks or robotic malfunctions. These alerts keep the system safe and stable, ensuring continuous operation. So, in simple terms, SCADA system alarms work by constantly checking data from equipment, detecting when something's wrong, and alerting operators instantly. They help keep everything running safely and smoothly, making sure problems are caught early and handled quickly. This is a key part of how automation and control systems keep our power and industries working efficiently.